At this question, I don't think we can use our substitution method, but the best method that we can use is actually the partial fraction. So look at the question. I'm having x raised power 4 minus 1, right? So first thing, what can I do here? My 1 raised power 4 is the same thing as writing 1. Yeah, it's the same thing. So I can just say let me just do it like this. X, let me equals to 0. Let me just say this one is equal to 0, right? Show that I'm going to have my x to be equal to what? X raised power 4 to be equal to that, I think, plus 1, right? So here I can have s squared multiplied with s squared, right, equals to 1. Then here I can have it to be s squared, shake it down, then multiply what? X, shake it down. I'm finding square root, or let me just say I find square root of both sides. I've squared the root of both sides, so I'm going to have my s squared to be equals to 1. Actually, breaking it down, I'm going to have my s squared to be equals to 1. So I can just have to x equals to what? Plus and minus root of what? Root of 1. See, understand it down. That means I'm having my s to be equals to what? That's plus or minus 1. It is very simple. So I just try to break this one down because looking at this, I'm going to have this square, you cancel this cancel this out, then s multiplied by x is what? S squared. Check it down. So this is my s squared here equals to what? Then squaring it, I'm having root of 1. The rest of it down. So that's just it. So without following this aspect, let's just go ahead and use simple algebra. Here I can just say this is s raised power 4 minus 1, right? I can change it to s squared minus 1 and also what? S squared plus 1. I can actually write this because by the time I expand it, I'm going to have this my answer back. Let's just go ahead and expand it. So expanding this, I'm going to have s raised power 4, this multiplied this, that's minus s squared plus what? Plus s squared, right, minus 1. So this will cancel this out. I'm going to have s power 4 minus 1. So it's very simple. So instead of me to just go ahead and use this like this, I can just rewrite it as what? As writing it as that's integral from 2 to 3, right? I'm having my 2x divided by what? That should be s squared minus 1 into brackets s squared plus 1 dx, right? So in this case now, if you look at what I just did here, I said s squared equals to 1, then s equals to plus or minus root of 1. It's still the same thing as this, because if I have something like this, I can just say this is, that's s squared minus 1 equals to 0. Then s squared equals to what? 1. I'm going to have s to be equals to what? Plus or minus what? Root of what? Of 1. Then s equals to what? Plus or minus what? Plus or minus 1. That means my s minus 1 and also x plus 1 can work, because here this is x equals to 1 or s equals to what? Plus 1. Minus 1 rather. You get now. So by the time I bring this side to this side, I'm going to have x minus 1 equals to 0, and here, or x plus 1 equals to what? 0. So that I can just have the factor to be x minus 1 into bracket x plus 1. So by the time I expand this, I'm going to have my x squared minus 1 back. So I can just rewrite this everything here as what? As integral 2 to 3, right? Then I'm going to have 2x divided by what? Divided by, that's x minus 1, right? X plus 1 into bracket s squared plus 1 dx. That's just it. So now let's go ahead and integrate. So going ahead and evaluate this integral calculus. Actually, the difference between the indefinite and also the definite integral is just what? The upper and also lower limit. That's just it. So the limit is just what differentiates the indefinite and also the definite integral from each other. So now let's go ahead and resolve this into partial fraction. I'm going to have 2x divided by what? Divided by x minus 1, right, into bracket x plus 1, right, into bracket s squared plus 1. Now let's integrate this together. Here, let's resolve into partial fraction together. Here I can just have it to be a divided by what? That's x minus 1, right? Then plus what? Plus b divided by what? That's x plus 1, right? Then plus, here I'm having quadratic function here, that is polynomial of degree 2. Then this is going to be cx plus what? Plus d divided by what? S squared plus 1. So that's just it. Now let's just go ahead and resolve it to partial fraction. So resolving this one into partial fraction, I'm going to have x minus 1, right, into bracket x plus 1 into bracket s squared plus 1, right? So which is equals to, that's 2x. Let's just assume that this has cancelled this out. That's just a waste of time, but let's just go ahead and just put it there. I'm going to have x minus 1 into bracket x plus 1, right, into bracket s squared plus 1. That's just it. Then I'm going to have this one to be, this will cancel this out. I'm going to have this one left. I'll be what? If into bracket x plus 1, right, into bracket, that's s squared plus 1. That's all, plus this will cancel this out, Abby. This will cancel this out. I'm left with these two. So I'm going to have my b into bracket s squared plus 1, which is this, into bracket again. I will have this x minus 1, right? Then plus cx plus d. My cx plus d, this is going to cancel this. I'm left with what? X minus 1, right, into bracket x plus 1. That's just it. So the funniest thing is that I can go ahead and open the possible bracket, but opening the bracket is going to be a long process. So that's going to just delay us. But let's just go ahead and just use trial and error. It's just trial and error method. Now look at this. I'm going to have looking at this, I have my x plus 1 here, which is a linear equation. I have my quadratic function here. This is actually a polynomial. Let me just use polynomial of degree 2, degree 1. No, degree 1 is a linear equation. So here I'm going to just take my x plus 1. Then my x plus 1 equals what? 0. Therefore, if x plus 1 equals 0, that means my x equals what? Minus 1. Making your x the subject. You are going to have x to be equals what? Minus 1. Then I'm going to put everything here into this equation, into everything that is here. So, but before that, let me just write them out. I'm going to have my what? My 2x, right? Then equal, this will cancel this out. Then I'm going to have equal a into bracket x plus 1, right? Into bracket again s squared plus 1, right? Then plus b into brackets s squared plus 1, right? Then I'm having it to be x minus 1. Then what again? I'm having plus what? Cx plus d, right? Then into brackets x minus 1 and open another bracket x plus 1, right? So this is just it. And I wish you can just open the bracket. Should we just go ahead and open the bracket? Let's open the bracket and just try to wait for it like that. We're going to have 2x equals to, this will give us a into brackets. This time this will give me x raised by 3, right? This multiplied by this, that's what? Plus x. This multiplied by this dot plus s squared, then plus 1. That's just everything I have here, right? So here let's go ahead, plus b into brackets. This time this will give me s raised power of 3. Then this time this will give me minus s squared. Then I'm going to have plus x, then minus 1. Let's close this. Then plus cx plus d into brackets. This time this is going to give me, that's s. I think everything else should just go as s squared minus 1, because x times x is s squared, then minus x plus x, then minus 1. So minus x and plus x will cancel each other. That's all it. So let me just call this one my goodness of a. That's equation a. So look at this. S times this is giving this. This time this is giving this. This time this is giving this, right? This time this is giving right. So now let's just go ahead and just look at this. Looking at this, I have a linear equation here. I have a linear equation here. I have a linear equation here, which is there are 2 here actually. So I'm going to set this one to be equal to 0. So let's x plus 1 equals to 0, just exactly as what I did here. So then I'm going to have my x to be equal to minus 1. Then I'm going to put my minus 1 inside everything here. Now the funniest thing is that whenever I just look at my x very well, putting x here, substitute your x as minus 1 here, putting it there, you're going to have it to be what? Minus 2 equals to. Now calm down and listen carefully. You're going to have x equals to minus 1, right? If you put minus 1 here, minus 1 plus 1, that's actually what? 0. Then a multiplied by 0 is what? 0. 0 multiplied by this is what? Is 0. That means my a is going to what? To cancel out, right? So my a has already cancelled out from this case. So equals to what of my b? My b minus 1. If I put minus 1 here, minus 1 square is actually what? Minus 1 square is 1. That's 1 plus 1. I'm having 2 here, right? Then this one is what? Minus 1, which is what? Minus 2. Then minus 2 multiplied by 2 is what? That's minus 4b. So I'll have it what? Minus 4b here, right? So I'm having minus 4b here. What of this case? Minus 1 plus 1, that's actually 0. So this time this is what? 0. 0 times everything here is also 0. That's just it. So now let's just look at this very well. I think let me just minus 1 or squared, that's actually what? 1. 1 plus 1 will give me what? 2. She get down, which is this 2. Then minus 1 is actually what? Minus 2. Minus 2 times this is what? Is 4. So in this case now, this we cancel this out, right? Sure that I'm going to have my b to be equals to, that's 2 by 4. 2 divided by 4, which is equals to what? That's 1 over what? Over 2. So our b in this case is what? 1 over 2. So now let's just look at another case now. Looking at another case now, look I'm having x minus 1 here also. So I can just say, let me just say, let my x minus 1 equals to 0. So therefore, my s equals to what? Plus 1. Then look at it very well. If I put my plus 1 here, nothing is going to happen. Because plus 1, that's actually what? Plus 2. Plus 2, right? So then, putting my plus 1, I'm going to have 1 plus 1, which is what? Which is actually what? That's 2 again, right? So it's very simple. Then looking at this, if I put my plus 1 here, everything here is what? Is 0. It shows that my b cancel out. Then putting my plus 1 here, everything here is what? 0. See, also everything here will cancel out. Then I'm left with what? With, that was actually my 2 into bracket 1, which is what? 2. Everything here equals to what? I'm having 4a. Yeah, exactly. Because this is 1 plus 1. 1 square is 1 plus 1. That's actually 2. Then 1 plus 1 is what? 2. 2 times 2 is what? 4. I'm having 4a also. Then divide both are what? 4. Divided both are 4. This cancels this. I'm going to have your a to be equals to what? 1 over what? Over 2. Our a is 1 over 2 and our b is 1 over 2. What's going on? All the best. So now let's just look at this very well. Now, I don't think I have any other equation that I can just use to get my c and d, but I can just go ahead and open these brackets very well. Then I will try to compare the coefficients, because that's the only thing I can do here. So now, looking at this, I'm going to have it to be what? To be 2x equals to what? Look at this. I'm going to have this to be what? Ax raised power of 3, right? Plus what? Plus a, right? Then plus what? Plus as square plus a, exactly. Then that's for my a side. I'm going to have plus what? Plus b s raised power of 3, then minus b s square, right? Then plus b x minus 1b, which is b, exactly. So now let's confirm it. This time this will give us this, right? This, yeah, right? Exactly. Can you see this now? So here a times x is what? Ax. Can you see this now? So it's good for to confirm. Then this time this will give me what? As square. Then this time this will give me a. Then I'm going to have my b times s cube, bs cube, then b times s square minus bs square, b times x. I'm having to be b times x, then b times minus 1 is going to give me to this. So it's very simple. So the next thing is that let's just go ahead and just expand this. Yeah, let's go ahead and expand this. No, I'll try to rewrite this one this way, because that's the best thing to do. So expanding this on its own, I'm going to have this time this will give me what? That's c s raised power of what? Of 3, right? Then this time this will give me what? Minus c x. Then I think that's all. This time this will give me what? Plus d s raised power 2. Then this multiply this will give me what? Minus d. So I think that's just it. That's it. So now all I just need to do is just to compare the coefficients, but I won't bother myself in this case. I will just go for my c and d, because that's just what we need to get in this case. So look at this now. The power of x raised power 3 at the left hand side is 0. The power of x raised power 3 at the left hand side is what? 0. Power of x raised power 2 at the what? At the left hand side is also was 0, right? But I'm having x raised power of 1, so I can just go ahead and say, okay, my c, I'll compare those that have what? S raised power 3 first. I'm going to have it to what? My a is having s raised power 3. That's what? A x raised power 3. Then I'm having what? That's plus what? Plus c s raised power 3, right? Am I having my b? Yeah, exactly. Plus what? B x raised power 3. What of d? I'm not having. Equals to 0. Can you see this down? Show that I can just divide all through by what? By s raised power 3. Divide. Let me just say all through by what? By s raised power 3. Then I'm going to have a plus c plus b equals to what? 0. So that's my first equation, right? Then let's do the same thing for d. D is having s raised s square, right? So the power of s square in this side is actually what? 0. So that means I can just compare those that have s square. I'm going to have my as square, right? Then minus, I'm having my bs squared, right? So then again I'm having what? Plus ds squared equals what? 0. That's very good. So in this case now, doing the same thing, I'm going to divide all by what? By s squared. I'm going to have a minus b, right? Then plus d equals to what? 0. Get right. And so therefore my d equals to what? That's bring everything in this guy. I'm going to have minus in the brackets a minus b. So that I'm going to have my d to be equals to what? Minus a plus what? Plus b. That's another equation 2. So these two equations are what I'm going to be using now. So looking at this, my A is what? My A is 1 over 2. That means I'm having 1 over 2 plus C is what? Unknown, then plus my B, which is what? That's 1 over 2 equals to 0. 1 over 2 plus 1 over 2, I think that's 1. So my C in this case is what? Is 1. Because 0.5 plus 0.5 is actually 1. So my C in this case is 1. Is it 1? Not just ordinary 1. It is minus 1. Because by the time I collect like times here, that's minus 1. So then let's just move to my D. My D equals to what? That's minus A plus B. Then I'm having my D to be equals to what? Minus 1 over 2 plus 1 over 2, which is equals to what? 0. So that's just it. So now let's just go ahead and what? And let's come back to this equation. Where is it? This is the equation, right? Show that here, my A in this case is actually what? That's 1 over 2. My B equals to what? 1 over 2, right? Then my C equals to what? Minus 1. And my D is equals to what? That's 0, right? So this equation will actually become 1 over 2 divided by what? That's x minus 1, right? Then plus my B is actually 1 over 2 divided by what? X plus 1. Can you see this now? Plus my C is minus, then I'll be having minus x. No, my C is minus 1, that's minus x plus D, which is 0, divided by what? S squared plus 1. Wow, everything is 0. It's actually making sense. So now let's just go ahead and just introduce our integral sign. So introducing our integral sign, I'm going to have integral. I'm not going to put limit in this case. I'm going to have here, I can just bring down my 2. I'm going to have 1 over 2 into brackets. Then I'm having x minus 1, right? Then I'm having plus again 1 over 2. I'm bringing down my 2, and I'm going to have x plus 1. Then again I'm going to have minus x divided by what? That's my s squared plus 1. Then I'm having dx. It's very simple, right? All the best. So now let's just go ahead and integrate this. I'm going to separate them one by one, and then I will integrate. Separating it, I'm going to have it to be I'll have this one to be integral of 1 over 2 into bracket x minus 1 dx. Let's deal with this first, right? So dealing with it, I'm going to have 1 over 2 integral of 1 over what? Over x minus 1 dx, right? So I can recall, if I should differentiate everything here and I'm having the same thing as just this, then that's ln, right? So here, okay, let me just try to solve this one for you, because I'm going to say let what u equals what? X minus 1. Then your du equals what? Dx. Your du equals what? Dx in this case. So come back here, I'm going to have 1 over 2 integral of 1 over what? Over u. My dx is what? Du. And you can recall, whenever you have integral of 1 over x, that's dx, that's what? Ln x plus c, right? So here I'm going to have it to be, that's 1 over 2 ln u, or you say log u. Then you can recall your u equals to what? X minus 1, right? So I'm going to have it to be, that's 1 over 2 natural log of x minus 1. Then am I going to add plus c? No, don't let me add plus c, because I'm actually integrating with limits. You understand that? So I'm going to evaluate it later. So let me just call this one my first one, which is equation 1. Now let's just go ahead. The same method is also applied to this. I'm going to have this to be what? 1 over 2 inertial log of what? Of x plus 1, right? So let me call this my second one. But the last one, if you look at the last one very well, I'm going to have integral of this negative integral of x divided by what? That's s squared plus 1 dx. So I'm going to use my substitution method here, because I can't just go ahead and say this one is just inertial log of, no, it's not inertial log. I'll use my substitution method. So u equals to what? S squared plus 1, right? So du equals to what? 2x dx, right? Then my dx equals to what? That's du divided by what? 2x. That's it. Then go ahead and put it back. We're going to have minus integral of x divided by what? Divided by, that's u, multiplied by what? My dx is what? Du over what? 2x. This cancel this out. Then I'm going to factorize minus 1 over 2 integral of 1 over u du, right? Which is also minus 1 over 2 inertial log of what? Of u. But if you can look at this now, my u is what? My u is something, right? So I'm going to record that my u is what? X squared plus 1. I'm going to have minus 1 over 2 inertial log of what? Of u, which is what? natural log of what? Of s squared plus 1, right? This is my what? My 3. So combining the integral of everything together, I'm going to have it to what? To be 1 over 2 the natural log of what? Of x minus 1, right? Then plus 1 over 2 the natural log of what? Of x plus 1, then minus 1 over 2 the natural log of what? Of s squared plus 1 plus c. I'm adding plus c. Let's say I'm asked to integrate. Let's say what I'm asked to integrate is actually what? Indefinite integration, right? That means it doesn't have limit, right? So in this case now, my c is going to represent the arbitrary constant. That's the constant for f of x. So now let's just go ahead and factorize this or simplify this. I'm going to factorize that. I can actually factorize my 1 over 2 out. 1 over 2, then I'm going to have into brackets, that's ln what? Ln x minus 1, right? Then plus what? Plus, that's ln what? Ln x plus 1, then minus what? That's s squared plus 1, right? So plus c. I can still go ahead and simplify it, right? But let's no way, don't let us waste our time. Then you can just go ahead and leave the answer like this. If it is you are integrating without limit, but let's say we are integrating with limit. Now in the case that we have integral of what? Of 2 to 3, right? So I'm going to have integral of 2 to 3 of what? Of 2x divided what? That's x squared, x is power 4 minus 1. The x is the same thing as what? That's 1 over 2 into brackets ln, that's x minus 1, right? Then plus what? Plus natural log of what? Of x plus 1, right? Minus natural log of what? Of s squared plus 1. Then I will have it from what? From 2 to what? To 3. That means I'm integrating from what? From 2 to 3. So let me just go ahead and integrate this and finalize the answer. So here I'm going to have it to be, since I'm integrating with limits, I'm going to have my 3 first. I'm going to have 1 over 2, then a natural log of what? Of 3 minus 1, right? Then plus the natural log of what? Of 3 plus 1, then minus the natural log of what? Of 3 squared plus 1. Exactly. So here I'm going to have 1 over 2 into brackets the natural log of what? Of 2 plus the natural log of what? Of 4, then minus the natural log of what? 3 squared is 9 plus 1, that's 10, right? So this is my first one. Let me just start it, right? So when my x, let me just say when x equals to 3, then when s equals to what? 2. Now I'm going to put it there. I'm going to have 1 over 2 into brackets natural log of what? Of 2 minus 1, right? Then plus natural log of what? Of 2 plus 1, then that's minus natural log of what? Of 2 squared plus 1, right? So in this case this turns to 1 over 2 into brackets natural log of what? Of 1 plus natural log of what? Of, that's 3 plus 1 is what? 3 plus 1 is, that's 3. 2 plus 1 is 3. Then minus natural log of what? 2 square plus 1, that's 5, right? So that's just my what? My second. Then I'm going to have it to be like this. Then 1 over 2 into bracket natural log of what? Of 2 plus natural log of what? Of 4 minus natural log of what? Of 10, then into brackets minus again. This is my upper limit and this is my what? Lower limit, right? So when s is 3 is my upper limit and when s is 2 is what? Is my lower limit. Then I'm going to have it to 1 over 2 into bracket. Then this is minus 1 over 2 into brackets natural log of what? Of 1 plus natural log of what? Of 3 minus natural log of what? Of 5. Can I see this down? So go ahead and solve this. Then make sure you drop your answer in the comment box below. Thanks for watching.